Okay, 1310, page 466 and 467. Area of triangles and parallelograms. So, we talked yesterday about the parallelogram a bit. We talked about why the rectangle formula, I mean, it works for a rectangle and a rectangle only with these terms, but parallelograms are similar to rectangles. They're four-sided figures. Similar that we're multiplying two values together to find the area. Difference would be that the side lengths. In a rectangle, the side lengths, the base and the height, are the exact same numbers you would use to find the perimeter. These two numbers I can use to find the area of this rectangle. These numbers are the same numbers I can use to find the perimeter of the rectangle. With a parallelogram, though, it's a little different. This over here, this side here, this is longer than 3 centimeters. The side length over here, it's the long side of the triangle. But that is not the height. That's a slanted height. A height is straight up and down. I mean, straight up and down here. If I measured from the floor to the ceiling, I wouldn't put a ladder up that touches the ceiling that goes out to here and measure the height of the ladder and say, oh, well, the ladder is 16 feet and it must be 16 feet tall. Well, no, we'd get right to the wall. We'd go straight up and down and say it's maybe 12 feet. So the height is always straight up and down. I mean, straight up and down. The height for any parallelogram, and I'm starting with the parallelogram here, always forms a right angle with the base. And you can see this little symbol here. We didn't cover it in too much depth this chapter. They covered it more in one of the earlier chapters, but this symbol represents a right angle. Right angles form 90-degree angles. They are perfectly straight and then perfectly perpendicular too. So you see the same thing with triangles. Triangles are the same thing, base and height, base and height, base and height. So starting with the parallelograms here, I'm going to start with number 5. They don't provide you any extra information. Next year there'll be other numbers thrown in there. It's not out of the realm of possibility that there could be a third number, such we could, well, let's just make something up and say this is 3.5 centimeters over here. And that is the side length. But side length is not what you use necessarily to find the area. It has to be a right angle form between the height and the base. So I know for a fact that this is the base. This is a side. Why? Because the height is always formed with the base. So this is indeed its side. Unlike the rectangle where it's hard to know what's the width and the length and the side, because if I turn it this way, it's still a rectangle. There's no real difference here, what I call the length and width. I just turn it around and around and around. It's still the same measurements here. But not so much with the parallelogram. So looking at number 5 there, it says find the area. And the formula that we kind of updated here, I wrote it a few different ways here.
Number 5?
Yep, on page 467. I'm doing the parallelograms first. Area equals base times height. In a sense, it's like length times width, but it's really not. So that's why I don't like using length times width even for rectangles, because base times height applies to rectangles too, but length times width does not apply to any other figure besides a rectangle or a square. So base times height's better. Parallelograms, rectangles are parallelograms. They're a variation of a parallelogram here. So you want to calculate this like this. So number 5 looks like this right here. Roughly speaking, there's my rough right angle. And two things I need to know. The base and the height always form a right angle with each other. But this would be my base right here. It is a side length. The height is not a side length at all. At this point here in 6th grade, those will have to be provided to you. Next year and beyond, we'll be able to do more information and find different things using Pythagorean theorem and other properties that we know true about right triangles that can allow us to figure out. We could figure out this side length using different concepts that we don't know today. So for now, in 6th grade, all this information will be provided to you. I mean, it shouldn't be terribly difficult to find the numbers you need looking at these. Base height, base height, base height, base height. Just like the rectangle, we're multiplying all these together. Ditto over here, base height, base height, base height. All we do is multiply these numbers together. The area of this parallelogram, the base, which is 4 centimeters, times its height, which is 3 centimeters. 4 times 3 is 12. A centimeter times a centimeter is a square centimeter. The answer should be 12 square centimeters for that here.
But the triangle one is 1/2 times 3 centimeters.
I don't know where my, it must be over there. And that's it. Find number 6. What is the area of the parallelogram? 12 inches, 18 inches. Here's my right angle right here. What is the area of the parallelogram? Brooke.
216. 216 what?
Inches squared.
Right. And again, how did I get it? Multiplied the base times the height. An inch times an inch is a square inch. Final answer, 216 inches squared. Pretty much identical process to the rectangle, but again, the big difference is in a rectangle, the side length is also the height right angles are formed all over the place here between the base and the height. Right angle symbols everywhere in this page here. So that's how I know it's the height. It forms a right angle with the base. But here, again, the side length does not form a right angle. This is not a right angle, that's not a right angle, none of these are right angles. So right angle is formed right there. And again, it's that dotted line is not a line segment or a part of the thing, it's just an internal line there to clearly demonstrate what the height of that figure is. That's why it's there, these red lines with the right angle symbol. So you know for a fact, especially when we talk about triangles, and again, they simplify it a bit for us here, but in the future, I could have a number here, a number here, and a number here. If I have all 4 of those numbers, how do I know which one of them is the base? If I got here, here, and here on the triangle, how do I know? Not necessarily, because that's not on the bottom, and number 3, that's up over there. So how do I know what number to use if I had a number here, 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 and here? If I had 4 numbers here, which one do I use? You always use the one that forms the right angle with the height. This forms the right angle with that. This forms the right angle. It's always the base and the height will always, and then when we do the trapezoids tomorrow, notice again, we'll see the right angles. Trapezoids have 2 bases. But again, the height will form a right angle with both base. We're looking for those right angles here. Wherever that right angle is where our height is. And whatever it's attached to is the base. So that way, if you have more numbers, and you're like, well, I got, if this is 9 feet and 7 feet here, and you're like 10, 9, 7, which one of those, what's my base? Well, it's this one. How do I know? Because this is the one where this is the segment where my right angle is formed.
That makes sense.
Right. So, and this applies forever for geometry here. I mean, this isn't just for now and next year we'll change the rules and stuff like that. Next year we'll throw more numbers at you, such as putting measurements of these here. It's up to you to realize I don't need those numbers to find area. If I was finding perimeter, Well, then I don't care at all about the height of this 8 feet would have nothing at all to do with perimeter, but I need to know what these two are to find the perimeter. 8 feet has nothing to do with perimeter. It's not even a side. Remember, it's exterior sides to find perimeter. So, there we go. Try number 8.
Okay.
And then we'll move on to triangles.
Oh my gosh, number 8. Oh, go stop, go. Chunky. So you are chunky.
So you should talk for yourself out.
Yeah. You act like that, you're gonna be like that. Oh, wait, you already are like that. Oh,
You guys are so nice.
You
we know.
and we'll go. Your name is like.
All right. What is the area of the parallelogram? Sig.
Okay. 3, no, yeah. Wait,
Yes.
yeah, 3 3/4.
What?
No. I just, okay, one sec. That equals,
What's the problem? How do I solve it?
okay, so you gotta do the improper fraction, so you do
Which is what times what?
5 times 1 is 5 plus 4.
What?
9.
Whoa. Say the improper fraction.
Yep. 5 times 1 plus 4.
Oh,
Yeah.
yeah.
Big bracket time.
Yep.
Equals 9/5.
Yep. There's
3
1.
times 1 plus 2 equals 5/3.
Right.
And then when you line it up, you can simplify the 3 and the 9, and then becomes a 3, and the 3 becomes a 1, and 3 times 5 is 15, and then 4 times 1 is 4, and then that's the improper fraction.
That was 1 4/5. 9 over 5. Not 9 over 4.
Oh, that's why.
So
I
the
got
5's
that.
both simplified. Final answer should be just
Let's
3 yards
go.
squared. And again, to solve with fractions, want to convert them to improper fractions. Multiply everything will simplify. You're just left with 3 over 1. The
Yeah, I
final
don't
answer should be 3 yards squared.
Okay.
Okay? Okay. Let's see. The book doesn't have a good picture of this here. Let's see if a different book has a better picture here, how this works here. They kind of show it with that here. They show it with this one triangle here. So here's what we need to know before we start working on triangle. So I'm looking up here, and what you see, the shaded green area is a triangle that they drew. Okay? See that there? There's my triangle right there. I see my base right there. Height is going to be a side length because it forms a right angle. This is a right triangle. But any triangle, if I make a perfect copy of it, which they do up here, they use it with this grid paper here, what shape is formed?
A triangle.
The triangle, when I copy the triangle and just place it on top of each other,
Yeah, square.
not a square, a rectangle.
Oh, that was
Or,
a square.
or more broadly speaking, a parallelogram. And you can do this with any triangle. Again, this isn't drawn to scale, but if I draw that triangle right there, right, and then I recreate the triangle, would you say that's about the same triangle there?
Yeah.
Notice how I've basically formed a parallelogram, where there's my height right there, there's my base, this is the same base, this is the same height right here, but essentially a triangle is just half of a parallelogram, because there's my triangle, there's the other half of it. When I put it all together, I've basically made a parallelogram, right? And I can do that with any triangle. I can do one like this, and then I can go down here and create the same thing. And if I turn it maybe on its side a bit or something, you can see, again, not drawn perfectly to scale, but generally that looks like a parallelogram again, doesn't it? Yeah? So, and that is true. A triangle is half of a parallelogram. It is half of a parallelogram. So, to find the area of a triangle, we do the same thing as we do as a parallelogram. We multiply the base times the height, but a triangle is half of a parallelogram. So to find the formula for area of a triangle, it's 1/2 times the base times the height. It's the same thing. I still need the base and the height, but whatever it is, I just divide by 2 or multiply by 1/2, whatever you want to do here. We say 1/2. Multiplying by 1/2 is the same thing as dividing by 2. They are reciprocals of each other. Multiply any reciprocals together, you always get a product of 1. So this is the formula to find the area of a triangle right there. You need the base, you need the height, you multiply them together, and then you divide it by 2 to find the area of a triangle. So looking at number 2. Number 2. And again, I can recreate it a little bit with the other thing here, but looks something like this. It says that's 10 feet, and it says that's 8 feet. So to find the area of the triangle, use my triangle formula, 1/2 the base times the height, 1/2 times the base, which is 8 feet, times the height, which is 10 feet. And then how I do it is I just pick an even number if I can and take half of it. Half of 8 is 4. 4 times 10 is 40. I did that in my head, but you can multiply half. If you have an even number, just take half of it. Half of 10 is 5. 5 times 8 is 40. Or do 8 times 10 divided by 2. I don't care how you get there. But you can see, again, if I recreate the triangle, right, because the whole thing here still has an height of 8, right? And this is still 10 feet over here. These sides are the same. They're identical. And then 10 times 8, the whole parallelogram would have a feet of 80 feet. And you can see there's my parallelogram now, right?
Because we used half of it. So
Right. A triangle is just half of a parallelogram. So that's, if you can process and understand what I'm saying here, it's easier to remember and apply some of this stuff here. That's why I'm trying to recreate it. But you can see, again, just like this triangle here, this triangle has an area of 6. And they did it with grid squares here, but you can count them out. Half of that square, half of that square. And it's kind of hard to see here, but if I recopy it, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. Half of that is 6. That thing has an area of 6 centimeters squared, right here. The other 6 is over here on this side. They're the same triangle, and it's always the same. So triangles are always half of a parallelogram, half of a parallelogram. So it's the same formula to find the area of a parallelogram, just half of it. Does that make sense? Why don't you find the area for number 3?
sitting right there. Okay, that's me.
So here's my triangle. What is the area of this triangle right here? I'll pull a stick here.
Would it be feet triangle? What?
All right, what do you think, Evangeline?
I got
180?
What?
7 meters.
Yeah. That's what I got.
What I got.
Times 30 times 12. Half of 12 is 6. 6 times 3 is 18. Add a 0.
Let's go.
I also got 180. Right.
No,
Not hard to do, especially in 6th grade. They don't throw extra information at you here. That changes next year. There'll be more info thrown at you, and it'll be up to you to figure out what pieces of information you don't necessarily need. I'll throw one at you, just see what you can do with it here. But if I had this triangle right here,
Wait, is this the star problem, the bonus one?
well, just see what you can do with it. See if you understand what I'm saying. I'll say this is 10 inches, 12 inches, 16 inches, and 20 inches. What is the area of that triangle?
Oh, I know this.
Door's open.
What the heck?
The door's open.
The door's open.
Go away. Open the door.
What's the area of this triangle here?
What? 100 inches squared.
You guys are all off track here. I don't care about the door. The door's open. It's up to them to turn the door on. Right. It is 100 inches. What? What do you want?
I have something.
Okay, great. The door was open the whole time. You could have just walked in there.
Shut the door.
What is this?
Okay.
Can't open it or shut it.
Anyway, for those that are paying any attention, this is correct because this is my base right here. This is not, this is not. How do I know? This guy right here is what I'm looking for. Whatever, we know this is the height. That's not hard to figure out. But I know this has to be the base because the base and the height always form a right angle with each other. No right angle formed here, no right angle formed here. There's my right angle. The base and height always form a right angle with each other. Always. Same thing tomorrow with trapezoids. They always form right angles with each other. So these things here, what's the perimeter of this thing?
48.
Right. The 20 plus the 12 plus the 16, sum of the side lengths. And of course, perimeter is not square units, just normal inches there. Right. So if I, again, these values have, or, you know, measurements have value. It just depends what exactly am I trying to do here. And again, in future years, you'll have to find these and this and find all sorts of different stuff. It'll spiral off and we can make hexagons and octagons and use what we know about trapezoids and triangles to find area and side lengths and Pythagorean theorems and trigonometry and sines and degrees and tangents and all this stuff will come together here. So it builds on this here. But anyway, I guess we'll just do a couple more here and
One
call
more.
it a day
Number
here.
5.
So
Oh, no.
9 through 14,
No.
very similar. You also have a table, 7 through 12 in your homework, 3 triangles, 3 parallelograms. They shift up. I'll do it sometimes, perhaps on a quiz or test. Same deal, except instead of giving you a visual figure of what's going on here, they just provide it to you. Here's your base, here's your height. What's the area of the figure? So, if anything, it's a little easier in my mind because it just apply the formula. So, make sure in your homework, this is triangle, this is parallelogram, slightly different formulas. So make sure that you're finding the area of the figure that they want. They want a triangle here, they want a parallelogram here. Those formulas are different. Parallelogram, base times height. Triangle, 1/2 times base times height. So make sure that you're using the right formula depending on what type of figure it is. So why don't you guys do numbers 10 and 13. Last two here.
I got 10.
Ooh,
I
6
think, feeling pretty I think I'll see you for science again today.
Yeah.
You will.
I know, no,
I think
Miss
Mrs.
Reedy. Miss Reedy.
Well, she has the 7th grade all that time, so I don't know how that's exactly
Well, she
gonna
said
work.
to come
But,
back down.
well, okay.
And then maybe
I'll talk to her when I'm over there for tech, but I don't have anybody during that time, so I don't know why she would have you guys and the 7th graders at the same time when I have nobody, but
Yeah.
I'll figure it. Whatever. I guess I don't care. I mean, if my choices are to have time all by myself for an hour or deal with you guys for 90 minutes,
Okay.
and after your science, we have our study hall together,
Really?
right? Well, I'm just, you know, I can sit here all by myself in peace and quiet doing whatever it is I do,
Means.
or I can deal with
Then
you
could
guys
be out
for
in the
90
cafeteria
minutes.
and just be
Right.
They don't
quiet.
bring the fit here anyway.
Right. So,
Yeah.
but
That's these things.
either way, we'll figure this out here with Mrs. Reedy. So,
Alright, I'm
but
done.
I'll probably tell her just send you guys to me. So,
So you want to deal with us.
Well, there's no reason for her to have two classes at once while I have classes. I mean, right? Right, so. The only logic is, both Mrs. Langland and Mrs. Reedy had an hour of free time this morning here, so I got no free time this morning, because 8th grade's gone, but,
You should get free time in the afternoon so we don't have
well
to be.
then, at that cost would be Mrs. Reedy having two classes at once for some reasons.
That might not go well, but it might go well.
I don't know, we'll figure it out, but if that's what she wants to do, I won't argue too hard. Okay, we got them.
Miss Reedy, in the middle of our test.
How long does this take here?
I've been done.
10:25. Again, look at that. We're already no dear time yet again due to
Let's
the
go.
very slow quiz that you took.
Hey,
I mainly chalk it up to lack of preparation on your parts.
Including you, Sig.
After that not really impressive homework that we checked,
Sig.
I chalk that up to you guys all sitting here not really focusing or working hard and all copying the same answers from each other.
I wasn't.
Well, I'm just saying.
I wasn't.
In my mind, it's pretty clear why the quiz took 17 minutes and it was difficult.
It took me 30.
My point is, as we continue on, I am telling you this chapter will pick up in difficulty quickly and a lot before it's done here. If you're not ready for what's coming next, what do you want me to tell you? So, if you spend your class time gabbing away in your study hall, all just sharing answers, well, you'll find your quizzes to be very, very, very difficult for you. Your quizzes will be very difficult. So,
We had some right ones, but some wrong ones. More wrong ones than right ones.
doesn't really matter. We'll see how the quiz went because you all got your 5 out of 5 homework, but your quiz is worth 20 points. That's 4 homeworks on there, so you want to get your quizzes right. Doesn't really matter if you're all sharing, whatever you want to do, but sooner or later you'll have a quiz, and later on after that you'll have a test, which you'll be doing on your own. You will not be all sitting here to gab it out. So if you don't know what you're doing on your own, then that's on you. So, I'm not saying this to be mean, I'm saying it to articulate that there seemed to be a difficulty today at a couple junctures in our day, both with the homework and the quiz, so. And now I'm telling you why it was difficult, right? Right. Do what you will with that info. All right, number 10, what's the area, Savannah?
42 and 84 hundredths.
If it was a parallelogram, that was correct, but it is a triangle, not a parallelogram. So the triangle, Damien,
What?
10.
Square, 42. Oh.
That's literally what Savannah just said. Jackson, not here, running out of sticks here. Dom,
25 feet squared.
no. 25, 8 and 4/10. You did number 9. I said number 10. Sierra,
21 and 42 hundredths.
21 and 42 hundredths, correct.
What?
I don't.
Oh, because
I did number.
That's on you. 8 and 4/10 times 5 and 1/10 is that, and then half of that. Divide by 2, there it is. Half of that. Triangle, 1/2 times the base times the height.
Whoopsie.
42 and 84 hundredths is a parallelogram. It says triangle, not a parallelogram. Other one, number 13. I've run out of sticks.
Me.
Anybody?
97 and 2/10 meters squared. Me.
No. Or wait. Yeah, 97 and 2/10. That is correct.
It's not squared, not.
Yes, it is.
All you do, it is b squared. 8 and 1/10 times 12.
You always
Parallelogram, 97 and 2/10.